How you doing? My name is Andrew Cole. This is my project one on flight arrestors. So intro and objectives. So for this project, we are presented with a block diagram representing a flight arrestor system, which uses a mass spring damper system, or rather a pair of mass spring damper systems to assist in bringing an aircraft to rest when landing on an aircraft carrier. Along with the mass spring damper, an AAG system was also explored, which uses two rotating drums set distance apart with fluid between the two drums, and they spin and provide a force that helps bring an aircraft to rest. Methodology. So using the diagram presented in the previous slide, was able to separate it out into three components revolving around each mass within the system and draw free body diagrams of the forces acting on each of those masses. Using those free body diagrams, I was able to solve them with respect to acceleration, which was used within the state space model. So figure 2 shows the free body diagrams used for the state space model in parts 1 and 2, analyzing the damping constant needed for a plane and a UAV to come to rest. And figure 3 represents the AAG system, which is defined a little bit differently. This one uses a force value in a different set of equations rather than part 1 and part 2. And table 1 just shows some problem parameters. So for the plane, that has a mass of 20,000 kilograms and is hitting the aircraft at 64 meters per second, or rather the aircraft carrier at 64 meters per second. And the UAV has a mass of 550 kilograms and hits the aircraft carrier at 35 meters per second. For both of these, it is intended to stop within 333 meters. And using the free body diagrams and from the previous slide, state space models for both problem 1 and problem 2, shown in figure 4 here, were able to be made, as well as in part 3 with the AAG system, a separate state space model was able to be made. And down here in equation 1, it shows how this was derived. So this one is in terms of length, which is L, which is the distance between the two drums, and V1, which is the initial velocity of the aircraft landing. And right here is just the Simulink model that was used to solve for these values. So for the displacement, the system is represented with two separate spring mass damper systems. So to get this, I just used a gain block of 0.5 to split whatever that the outputs of one system were into two, or rather the net system into two separate components. And results. So figure 7, 8, and 9 represent the damping constant of 2400 being used to bring the plane to rest. So using 2400 as a damping constant, I was able to get the plane to stop in 330 meters. As you can see, it comes up, reaches a nice peak up here, dips back a little bit before coming to rest. This motion is also represented in 8 and 9, showing the velocity and acceleration of the plane. Figures 10, 11, and 12 represent similar things to the previous slide, but now in terms of the UAV. So using a damping constant of about 50, I was able to get the plane to come to rest in 192 meters. And this motion is also described with the velocity and acceleration in figures 11 and 12, respectively. Figures 13 and 14 represent part 3 of the project, where the AAG system was used to bring the plane and UAV to rest on the aircraft carrier. So using this model with the AAG, the plane was able to come to a complete stop at about 890 meters, and the drone, or rather the UAV, was able to come to a stop in about 620 meters. Given that these values are over the 333 meters that were allotted for the landing, a gain block was used after to help bring these values down. So using a gain of 0.1 for the plane, was able to stop it at 320, and a gain of 0.25 was able to bring the UAV to stop in 310. Obviously, in the real world, would not work like this, but with the state space model, I was only able to get the accurate results for higher stopping distances. So for the spring mass system, damping constant of 2,400 meters, or a damping constant of 2,400 was needed to stop the plane within 333 meters, and a damping constant of 50 was needed to stop the UAV. And for the AAG system, I found a range between 1.4 times 10 to the minus 5 and 6.5 times 10 to the minus 4 meters for the range of distances between the drums. And that is for the plane and the UAV, respectively. So in conclusion, so free body diagrams of the system were drawn out to identify the forces on the system, and using the free body diagrams and the sum of forces equations at each location, state space models were able to derived and put into a Simulink model to model a plane landing on an aircraft carrier. Thank you for listening.